Good morning to one and all. Now we are going to see Unit 2 in Block 1. Already in Block 1, we have seen about the scope of operation research, applications, and also various techniques, and also the fields, disadvantages, everything. All these things already we have seen. Now we are going to see about Unit 2, linear programming problem and its formulation. Already in the introduction topic itself, we have discussed that linear programming problem means it will contain the objective function and finding the solution for that function by having some constraints. By having some constraints is said to be called as linear programming problem. So what is the structure? What are all the structures here we are having means objective, that is objective for the linear programming problem, introduction to the linear programming problem, definition of linear programming problem, components of linear programming problem, applications of linear programming problem, limitations, that is disadvantages of linear programming problem, mathematical formulation of linear programming problem, steps for forming a linear programming problem, and based on these topics, we have to see some worked out examples, overall sum up and keywords what we have used here and some questions to be answered. So all these things are the thing what we are going to see in the linear programming problem. Now we can come for the objectives. Objective means after studying this unit, we will be able to formulate the linear programming problem and identify the characteristics of that linear programming problem and make a graphical analysis for that one and solve the problem graphically. So if you're by reading this, that is by overcoming this unit, what is the thing you can do it here means you can identify the characteristics and also you can make a graphical representation of the problem, and by using the graphical representation itself we can solve the problem because you have to find the answer for objective function. We have to find the answer for our objective function itself. Now we can come for introduction. That is, what are all the things needed for that linear programming. Linear programming is a special and versatile technique which can be applied to a variety of management problems. That is advertising, distribution, investment, production, refinery, operations, and transportation analysis. For all these types, we can use a linear programming model and solve the objective function, we can get the solution. The linear programming is very useful not only in industry and business, but also in non-profit sectors. It is not only useful for business and industry, but also for the non-profit sectors such as education, government, hospitals, and libraries. For solving the problems, we can use the optimization technique by using the linear programming problem. The linear programming method is applicable in problem characterized by the presence of decision variables. Generally, variables means alphabets only. So all the decisions can be represented in terms of the decision variables, and by finding the solution for the decision variable, we can solve that problem. That is, you are finding the value for the decision variables means the result were obtained. That is meaning. It will come under what means non-linear programming. So mainly what we are using here means linear problem only. The decision variables represent quantities that are in some sense controllable inputs to the system being modeled. An objective function represents some principal objective criterion or goal that measures the effectiveness of the system, such as maximizing profit or productivity or minimizing cost or consumption. Already we have discussed in the unit 1 itself, the optimization technique is merely used for maximizing the profit and minimizing the time and cost. So that is the major aim. So that can be solved by using the linear programming problem also. There is always some practical limitation there is always some practical limitation on the availability of resources. That is, limitations means there must be some constraint because like this much is only available. Only we can use this type of resources. That is nothing but the limitations. So the limitation occur in terms of what means man, material, machine, or time for the system. These constraints are expressed as linear equations involving the involving the decision involving the decision variables, and solving a linear programming problem means determining actual value of the decision variable. So this point is very, very important here. That is, solving the linear programming problem means you have to find the value for the decision variable. So already we told you, no, that is decision variable means only x, y, z or alpha, whatever may be that from A to Z. You can express in any variable. So if you're finding the value for the decision variable means that will optimize the objective function means that is the solution for the given linear programming problem. So the limitations imposed by the constraints. Constraints means condition. So the main important feature of linear programming model is the presence of linearity in the problem. So the power must be all the time one. The use of linear programming model arises in a wide variety of applications. Some models may not be strictly linear. If it is not linear, but can be made linear by applying appropriate mathematical transformation. If it is not linear means we can convert in terms of linear. Still, some applications are not at all linear, but can be effectively approximated by linear models. The ease with which linear programming models can usually be solved makes an attractive means of delaying, that is, dealing with otherwise intractable nonlinear models. Now we can come for the definition of linear programming model. That is, it is defined as the process of considering various inequalities in a situation and estimating the best value that may be obtained under those circumstances. So a linear programming problem means it must have some inequalities, and if you are finding the best value means it is nothing but the solution for that problem. And next one is components of linear programming problem. The basic components of the linear programming problem are as decision variables. The variables whose value determined the solution of a problem are called the decision variables. Already we know that the decision variables means we have to find the value for that variable. You can assign any variable. You can have any variable according to our assumption. And constraints. Constraints means the condition subject to a set of simultaneous linear equation. That is known as what means constraints. With the help of the constraints only, we can find the value for the decision variable. Next one is objective function. The linear programming problem deals with the optimization. That is, either you can maximize or minimize. Already we know that is, maximization means you have to maximize the profit. Minimization means minimize the time or inventory cost. That is nothing but the optimization. Either you can maximize or minimize. So this is nothing but the idea here of what we are going to use means either you can use maximization or you can use minimization. Next one is nothing but the application of linear programming problem. Where and all we can apply our linear programming problem. Industrial, business, economic, military, distribution, and marketing. All these are all the areas where we can apply the linear programming problem. And limitations of linear programming problems are where and all we can't apply linear programming problem means even after determining the objective function, defining the constraint is difficult. If it is finding difficult to define the constraint means it is said to be the drawback. And it is only suitable for standard conditions, and solution earned by the LPP may not be integer at all the time. That is, you won't be getting any round off number. The value yielded by the linear programming problem may not be an integer. So all these things are all the disadvantages faced by us. And the next thing is the how to formulate the linear programming problem. Mathematical formulation of linear programming problem means how can we frame in mathematics, that is mathematical modeling. That is, if xj, where j varies from 1 to 3 up to n, the n decision variables And if the system is subject to a constraint, then the general mathematical model can be defined as maximize or minimize is equal to f of x1, x2, x3 up to xn. That is, your objective function will be like this only. Either it may be maximize or minimize is equal to f of x1, x2, x3 up to xn, subject to some condition. That is subject to C1, x1, x2, x3 less than or equal to or equal to or greater than or equal to vi. And structural constraints x1, x2, x3 are greater than or equal to 0 are called as non-negative restriction. So what is the mathematical formulation is showing here means either you can maximize or minimize with some condition. So this is the format for the structural constraint for the mathematical formulation of the linear programming problem and steps for framing a linear programming problem. What are all the steps involved to solve the linear programming problem means first you have to identify the unknown decision variables to be determined and assign symbols to them. First you have to identify the decision variable. That is, if you are finding the value for the decision variable means that will give the solution directly to them, and identify all the restrictions or conditions in the problem and express them as linear equations. So all the conditions must be expressed in terms of equations or inequalities. Equation means equal to symbol. Inequality means greater than or equal to, less than or equal to. So whatever may be that we can find the solution for that by using the linear programming problem. The next one is identify the aim or objective and represent it also as a linear functions of decision variables. Everything we can find it in terms of decision variables. And finally, express the complete formulation of LPP as a general mathematical model. So you have to finally formulate an LPP as a general mathematical model itself. Now, we can see some of the worked out examples here. What is the thing here we are having means a firm produces 3 products. So how many products we are having in our hand means 3 products. These products are processed on 3 different machines. So these products are processed in 3 different machines. The time required manufacturing 1 unit of each of 3 products and the daily capacity of 3 machines are given below. So here in this table, what are all the things we have provided you here means mission 1 means what are all the products, how many they are producing and the capacity of the mission they have given. So this table is representing all the values. It is required to determine the number of units to be manufactured for each product daily. So you have to find out how many units each, that is how many units that they are manufacturing for each product daily. So almost we are having only 3 products. So how many things they are producing that we are in need. The profit per unit per product is 1, 2, 3. 1, 2 and 3 are rupees 4, rupees 3 and rupees 6 respectively. So what are all the profit? From product 1, they are earning the profit as rupees 4. And from profit 2, they are earning the profit as rupees 3. And from product 3, they are earning the that profit as rupees 6. So it is assumed that all the amounts produced are consumed in the market. Formulate the mathematical model for the problem. So this is the question. You have to give the mathematical way of representing the data there. So what is the profit they are having here that we are having already, and the products produced by the mission 1, 2, everything is given, and also the capacity for the mission is also given here. Now we can see how they are framed in terms of the mathematical model. Your solution is x1 be the number of, you have to give some decision variable for all. So your major thing is nothing but the products. So if product 1 is represented by the decision variable x1, product 2 that x1 is nothing but the decision variable. If you're finding the answer for the decision variable means that is nothing but the solution. So x1 be the number of units of product 1, x2 means the number of units of product 2, and x3 means the number of unit of product 3. So you can express all these product by the means of decision variable. The capacity for mission 1 is 440, capacity for mission 2 is 470, and for mission 3 is 430 daily. They have given that the capacities also. So all these things can be expressed in mathematical format as you can see that first row, that is in the first row, the product given by the mission one is 2, 3, and 2. So you can already we are having x1 as a decision variable for product 1, x2 as a decision variable for product 2, and x3 for product 3. So 2x1 plus 3x2 plus 2x2 is less than or equal to 440. Is less than or equal to 440. So that is the first equation. Second equation, how can you frame here means by making use of this data. That is for product 1, that data what they have given is 4. There is no product from the machine to from product 2. That is, it can be represented as 0x2. And product 3 means it is what they have given to you here means 3. And another one is 470. So what can be expressed here means 4x1 plus 0x2. There is no need to write that. So 0x2 plus 3x3 is less than or equal to 470. And the last, what they are having here means mission 3 means you can say this one as 4x1 plus 5x2 plus 0x3. But there is no need to write that. It is less than or equal to 430. So all these integers, that is x1, x2, x3 are greater than or equal to 0. That is non-negative integers. So you are formulating the constraints. So conditions from the table, you are formulating the conditions there. And the profit per unit for product 1, 2, and 3 are 4, 3, and 6 respectively. So we can take that profit value and we can write it in terms of the objective function. That is maximize Z. Already we know no. Profit means it is only maximization. So the objective function is maximize Z equal to 4x1. Already they have given in the question itself. That is profit means for how many rupees they have given 4, 3, and 6. So it is nothing but what means 4x1 plus 3x2 plus 6x3. So this is nothing but the objective function. And the conditions we have framed from the table itself. So this is a model for the linear programming problem. This is the format. So whatever the question they are giving means you just to see what is given in the table, the data values, what it is representing majorly, and what is the objective function. Most probably all the constraints, that is conditions, will be given in the table itself. And apart from that, if any other thing is given means you can take it as our objective function and we can make a decision variable by ourselves itself. That is, if it is if you are having only product 1 and product 2 alone means we can keep the decision variables as x1 and x2 itself. If you are having product 4 means how many variables you will be having? x1, x2, x3, and x4 also. So according to your given data, you can frame the decision variable by yourself and the conditions you can fit from the data itself. Can fix from the data itself. And the objective, you have to see what is the question they have asked. So this is the mathematical formulation of the linear programming problem. Example 2. What they are giving in example 2 here means a company owns 2 floor mills. So how many floor mills we are having here means A and B. So two decision variables are needed. So the main thing here is 2 mills. So two things, that is 2 floor mills we are having. So what are all the decision variables we are requiring here means x1 and x2, or else we can take it as x and y, or else we can take it as c and d, whatever may be that according to our assumption we can take it, which are different production capacities of high, medium, and low quality floor. So they are distinguishing their capacities as high, medium, and low quality floor. And the company has entered a contract to supply floor to a firm every month with at least 8, 12, and 24 quintals of high, medium, and low quality respectively. And it cost the company rupees 2,500 per day to run mill A and B respectively. So here you are coming across 2,000 and 1,500. No. So you can keep that one as what means objective function. That is objective function means maximize z equal to something. That is 2,000. plus 1500. So if you are having the amount range means we can have those things as our objective function on your day. So first you should understand what is your decision variable and what is your objective function and what are all the constraints. So all these things you have to identify from the question itself. On a day, mill A produces 6, 2 and 4 quantals. 4 quantals of high, medium, and low flavors flows, and the mill B produce 2, 4, and 12 quantals of high, medium, and low flows respectively. So, how many days per month should each mill be operated in order to meet the contract most economically? Most economically. Now, now we can assign x1 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 as what means mill A, and you can assign x2 for mill B. And the objective is to minimize the cost of the machine runs and to satisfy the contract order. That is, what are all the amounts we are having here means rupees 2000 and rupees 1500 for maintaining the machine. So for maintaining the machine means we have to put some investment for maintaining the machine. So your profit only maximize, but for investing the amount, it should be minimized only. So what's the thing we have to use it here? What's the thing we have to use it here means minimize is equal to 2000 x2 plus 1500. That is 2000 x1 plus 1500 x2. So you have to give that one detail. That is minimize is equal to this one. And mill A produced. What are all the things they have given already in mill A means 6, 2 and 4 quantals of high, medium and low quality flour. Mill B produced 2, 4 and 12. So all these things we can enter here. Here there is a mistake. 6x1 plus 2x1 plus 4x2. That is x1 here. But here the printing mistake is 24. So we have to convert that one. So 6, 2 and 4 in this first column. Another one is 2, 4 and 12. This thing is for mill B. X2 and all it is dealing only for mill B. And this X1 is and all for mill A. So you are writing in this order. So you have to identify that one. So that is 6x1 plus 2x2 greater than or equal to 8. 2x1 plus 4x2 greater than or equal to 12. That 8, 12 and 24 and all had been given here itself. That is 8, 12 and 24 here. So by your mill A and B only are there. So you can fix that one as x1 and x2, and all the details we can enter this one as what means the constraints. So what is the objective function here means your objective function is nothing but minimize z equal to 2000 x1 plus 1500 x2, and the mill A produces some quantals according to high, medium and low, and mill B produce some other quantals. That's all. So if you're framing that one means you will be getting the format for our linear programming problem. So what is the above example they are saying here means the above example is for maximization, maximizing the that is product. And the next thing what we are seeing is we are minimizing. So you can identify the way where you have to use maximize and where we have to use minimize. That's a thing we can do it here. And overall sum up. Sum up means in this unit, students able to formulate a linear programming problem. That is, we can formulate a linear programming problem by identifying the characteristics of linear programming problem and make a graphical analysis of linear programming problem and solve the problem graphically. So everything we can do by making use of this unit clearly. And the next thing is nothing but the keywords. What are all the keywords used here means in this unit we can learn about how to formulate LPP. LPP means it is a short form for the linear programming problem, identifying the characteristics of linear programming problem and make a graphical analysis of linear programming problem and how to solve the problem graphically. So all these things and all nothing but the keywords. Okay. So the linear programming problem means we can express in terms of what means LPP. Now, We can have some other questions also. All these questions and all we can practice. So we know what is the objective and we know what is the constraints you have to follow for framing the linear programming problem. Here, so far, what are all the things we have seen here means we have seen the basic definitions for the linear programming problem and the mathematical formulations, objectives. Here, what are all the things we are having here means we are having the introduction part, objective, introduction to the linear programming problem, and you can understand what is a decision variable and also the definition, exact definition for linear programming problem and the components. I mean in linear programming problem means what and all must be there. That is a component and then application of the linear programming problem where and all it can be applied and also the disadvantages of using the linear programming problem and mathematically how can we formulate the linear programming problem. Either it can be maximized or minimized under some conditions, that is a mathematical formulation. And what are all the steps for framing the linear programming problem. Steps means it is nothing but what we have seen in the problem. You should identify the constraints and also the objective functions neatly there. So these are all the steps and some worked out. Here we have seen some worked out example, one for maximization and another for minimization. So maximization means mostly 99% we will be using for profit. We have to increase our profit. Minimization means we have to minimize the time and cost. That's a minimization. Where and all we will be coming across a problem like this, we will be using what means minimization only. Where and all we have to increase the profit means we have to apply the maximization only. So this is a two category there. And so far these things and all only we have seen. And now we will be seeing some terminal questions there. That is with the help of the questions what we have solved. We can see some other questions also here. What are all that one means? A company produces refrigerator in unit 1 and heaters in unit 2. So one company only producing refrigerator. Another company is that is the same company is producing heaters also. So one is done in unit 1, another one is done in unit 2. The two products are produced and sold on a weekly basis. These two products are produced and they are sold in a weekly basis. Weekly basis means per week how many refrigerators they are selling, how many heaters they are selling. That is the theme there. And the weekly productions cannot exceed 25 in unit 1. For unit 1, it should not be more than 25. And for unit 2, it should not be more than that is 36. Due to constraints, 60 workers are employed. Due to that, some factors, only 60 workers are employed. Apart from that, a refrigerator requires 2-man week of labor, while the heater requires 1-man week of labor. The profit available is rupees 600 per refrigerator and rupees 400 per heater. Formulate the LPP problem. So what is our aim means we have to formulate the linear programming problem. So linear programming problem, if you want to formulate means initially we have to find out our decision variables. So decision variable means how many factors are here. Only we are concerning with refrigerator and heater. So one thing refrigerator we can keep it as x1 and heater we can take it as what means x2. So you have to write the profit. Actually in the question itself they have given the keyword profit. Profit means it is maximize. So profit means how can we represent it as maximize only. So maximize z equal to 600 x1 plus 400 x2. Mostly if they are representing by rupees means it should be the objective function. So already we know no, objective means either to maximize or to minimize. So maximize z equal to 600 x1 plus 400 x2. And what are all the constraints we are having here that we have to see here. Refrigerator. A refrigerator is giving how much man means 2-man, but a heater gives 1-man. So 2x1 plus 6, that is 1x2. it is nothing but less than or equal to 60, because the water thing they have given in the previous sentence means only 60 workers are employed here. So for working labor, you can make the constraint as what means 2x1 plus x2 is less than or equal to 60. And specifically, they have given that the weekly production cannot exceed 25 in unit 1. So for x1, unit 1 means for refrigerator, it should not be more than 25. So x1 must be less than or equal to 25. And for heater, it should not be more than 36. So x2 must be less than or equal to 36. So these two things, that is, these three things are nothing but the constraints needed for maximizing your objective function. So what are all the things we are having here means, so what are all the keys we are having here means the profit, if you are having profit if they are mentioning means definitely you have to use maximize. And if you are having anything in terms of rupees, you can write that one for our objective function by representing in terms of the decision variable. So maximize are equal to 600 x1 plus 400 x2. Similarly, what are all the conditions they have given to you? That alone, it will be somewhat confusing, but anyhow, if you are practicing more problem means, it would be somewhat easy one. We can do everything neatly. So we have to see some constraints also there. Now we can see for our next example. What is our next example means a television company operates two assembly section. So a company is containing two assembly sections. What are all they means? Section A, another one is section B. So section A, you can take it as X1, and section B, we can take it as X2. So you can categorize that one. What is how many categories we are having, that you can see it neatly there. And then here we can see that each section is used to assemble the components of three types of televisions. So section A can assemble. Assemble means can join. Which and all they can join? They can join the three types of television means color, standard, and economy. So first section can take over what and all means color, standard, and economy. So these things and all will come under section A. The expected daily productions on section A sections for each section as given as that is TV model, color, section, and economy. And section A, how much time it is taking for coloring means 3, standard means 1, economy means 2. Similarly, for section B, color means 1, standard means 1 unit, and the economy means it is nothing but 6 unit. The daily running cost for the daily running cost the daily running cost for two sections average is rupees 6,000 for section A and rupees 4,000 for section B. So running cost they have given. So running cost means what's the thing we have to do for that one means you have to minimize. Definitely we have to minimize. Only if you are seeing the word profit only means you have to maximize. And if we are seeing time or cost means it is nothing but minimize only, definitely. So minimize is it equal to what are all the things we are having? 6,000 x1. That is what are all the decision variables. That is section A means you can make it as x1. Section B means you can make it as what means x2. So what is the thing we are having for section A? That is daily running cost 6,000. And for section B, the running cost is nothing but 4,000. So you can see that is if you're seeing the cost itself, you can fix the word minimize Z. So what's the thing we are having here means minimize Z equal to 6,000 x1 plus 4,000 x2. Since your decision variables are x1 and x2, we can complete the objective function like this. And we have to frame some conditions. What are all the conditions we are having here means already in the table itself they have given to you neatly there. That is section A, all will comes under x1. and the section B means all will comes under X2. So section A means what are all the things we are having? 3, 1, 2. So everything we can write it as 3x1 plus x. That is 3x1, x1 plus 2x1. That is, you can see this first column. This thing is the first column is nothing but all the terms regarding to section A. Similarly, second section B is nothing but the decision variable x2. So all these things are nothing but the terms we can write it in x2 itself. That is 1x1 plus 1x2 plus 6x2. So everything we can write it like this, and with this side is some completely, it is somewhat okay. And this minimization is, it is equal to 6000 x1 plus 4000 x2 is also an objective function is okay. And the constraints is also some we can frame from the table itself. And how we have to frame this right hand side means, what is the thing they have given to you here? It is given that the company must produce at least 24 colors, 16 standard and 40 economy TV set for each order in pending. So for each thing, what are all the things we are having means 24. So if you are having section A and section B like this means it should have 24 colors. Coloring 3x1 plus 1x2. So 3x1 plus 1x2 must be greater than or equal to 24. Why we are using greater than or equal to symbol here means, here they have given to you at least. Generally, at least can be written as what means greater than or equal to. At most means less than or equal to. So if you are having the word like this, at least means we can use the inequality as what means greater than or equal to. So colors means how much it must be means greater than or equal to 24, and the standard means it must be greater than or equal to 60, and economy means it must be greater than or equal to 40. So all these constraints are formulated here. So this is nothing but the formulation of LPP here. So we can clearly visualize where and all we have to use maximization, and where and all you have to use our minimization concept properly here. And we can set our objectives according to our goal. According to our goal itself, we can set our as that is what means our objective functions. Greater than means where and all you will be getting greater than or equal to, less than or equal to also you can see from the question itself. If you are having at least, if you are having at least, it must be greater than or equal to. If you are having less than or at most, you can see it as what means less than or equal to. So this is the formulation for our linear programming problem. In such a way, we can have many number of examples also. So what are all the things we have seen so far? Here means the structural part of the unit, that is in this unit 2, what are all the structures we are having. In that one, what are all the things we have seen means basic definitions, components means what are the things needed for setting the linear programming, and applications, and the next thing is limitations, and for mathematically how can you represent that, and what are all the steps needed to formulate the linear programming problem. And we have seen some worked out example. Sum up means overall sum up, and keywords, and terminal questions, and also some terminal questions was also there. So in the introduction itself, we have understood that the linear programming problem means it power, that is the decision variable must be linear. Decision variable, the what we have seen in the example itself, all the decision variable what we have seen, x1, x2, x3, the power for that x1, x2, x3 and all is nothing but power 1 only. We didn't see any power more than that one. So the decision variable represents the quantities, and each decision variable can represent some quantities. Each decision variable can represent some factors, something they can represent. So all these things only we have seen in the that is overall introduction. And the definition means it is nothing but the process of considering various inequalities in a situation and estimating the best value. And what are all the components? Components already we know. I think we can understand very well what's the meaning for decision variable, what's the meaning for the constraints, and what's the meaning for the objective function. So this three component is very, very important for the linear programming problem. And what are all the applications of linear programming problem means? Generally, it has been used in the field of industry for making their profit more, business for making their profit more, economic, military. Military means to how to make less man resource. Military means we should not invest more. So in this case, you will be having only minimization and then distribution in the sales sector and marketing. So these are all the fields where we can apply the methodology of linear programming problem well. And what are all the disadvantages? What are all the limitations we are coming across while applying the linear programming problem, and mathematically how we are framing the linear programming problem. So this thing also, if you are doing some problem, it could be quite okay. And the steps involved in framing a linear programming problem, you have to identify the decision variables and some restrictions what we are having here. So all these things you should have it in our mind clearly. And we have seen some worked out examples. And from the question itself, if you are seeing the keyword properly means you can frame the problem very well. That is, profit, if you are saying means definitely it should be maximized. So in this problem, the word profit is given here. So definitely it will comes under where means it will comes under maximization only. And according to our table, according to the given table, you can fix according to the table, you can frame our constraints very well. So we have to view the problem neatly 1 or 2 times. Then only we can understand the concepts clearly, and then we can arrange the objective function and the constraints. Otherwise, it won't be possible at all. And similarly, in the next question, what is the thing they have given to you here means economically. And one more thing also, if you are seeing economically, that is economically, if they are completing the question like that means what we can have there means you can minimize. Generally, economically, economy means what? You can, what's the thing we can say there means we can minimize the manpower. We can minimize the cost of maintaining. Likewise, only economically, how can we manage? Likewise, only we can see there. So if you're seeing economically means it is nothing but minimize. Likewise, also we can have some clues in our question itself. So here, what's a keyword they have given to you, given to us means here they have given to us nothing but economically. So economically means it is nothing but what means mainly less. It is nothing but mainly less amount only. So it is nothing but what means less than or equal to, that is, it is nothing but what means minimization type only. So we can identify that objective function from there. So and here we are already seeing the sum up and also the keywords. And in this terminal questions also, what's the thing we have seen there means in this terminal questions also, from the question itself, what's the thing we are seeing there means profit. We can identify the word profit. So profit means definitely it should be maximized only. So from there itself, we can identify our objectives clearly there. So the objective function we can set neatly there. And from the second terminal questions, what we are having here means in the second terminal questions, they themselves have given that formulate the LPP to minimize the total cost. So minimize means the cost and time, definitely it must be minimized only. Thank you.